In this video, I will show you how to write a single menu driven program for all the operations upon an array. So we have seen various operations upon an array, and I am using the same project. See, in this project, initially we have defined an array. Having the members, this is the pointer for an array, and this is the size and the length of an array. See, I have changed it to a fixed size array, and I have shown you all the functions. Now back again to a pointer so that we can have an array of required size. Then I have all these functions: display, append, insert, delete, swap, linear search, binary search, and recursive binary search, get, set, max, min, sum, average, reverse, and recursive reverse. Second method for reversing, and inserting in a sorted array, then checking whether array is sorted or not, rearranging the elements, merge, then union, intersection, difference, all these functions we have seen. So in any application, if you require an array, you can use that one. But here I will show you a menu driven program where we can use all those functions. So let us write a menu driven program. First I will declare an array arr1. If any other variables are required, I will declare them. So first of all, I should know what is the size of an array I want, because there is a pointer and I should dynamically create an array and assign it to that pointer. So I will take it from keyboard asking what is the size. So we have already seen how to take the input from the keyboard and create an array of required size and also fill the elements. So I will finish the code for creating an array of required size. Yeah, here initially I am asking the size of an array and taking the size of an array and then creating a array inside heap and assigning it to a pointer A. Now here I will write the code for menu. Let me finish the code, then I will explain. Here I have prepared the menu with a few options like insert, delete, search, and finding sum, and then displaying an array. You can add all other options like reversing an array, checking if it is sorted or not, performing union, intersection, or merging. All those operations you can provide. I'm just giving the idea how you can prepare a menu driven program, so few options are there. Then here I'm asking enter your choice. So let us say ch is a variable here, in that a choice is taken. Then using switch case, I can call the corresponding function for each options. The options are having numbered from 1 to 5. So whatever the option is given, I will call corresponding function. Here I write switch case upon ch. See case 1, first case. In the case 1, I should call insert function. So for that, I should know the value that I want to insert and the index at which I want to insert. So I will take those things from keyboard, enter an element and index. Then scanf, I should read two values, the value to be inserted. Let us take it in the value to be inserted and index. So x is for the value and index is for location where we want to insert. So and these two variables are already declared here. I have those two variables. When I have these two things, then I should call function insert by passing address of an array 1 because it is called by address, then index at what I want to insert an element, then also x. That's all. Break. Likewise, I will fill rest of the cases, delete, search, sum, and display. I will finish rest of the cases, then we will continue our discussion. Switch case is ready here. This is the first case for inserting an element. Now I'll explain you the second case. For deletion, it's asking an index, then it will delete an element, then it will print the deleted element. In the third case, we want to search. Search is a key what we want to search, then call linear search function by passing key and it will return the index, and the index of that element is displayed here. Then fourth option is for displaying the sum of all the elements of an array. So I am calling sum function and directly displaying the result here. Then fifth option is display. So that's all. Sixth option is for exit. So better I will write on this entire thing inside a loop. So I will use do while loop so that this menu repeatedly appears, and this should be do while choice is less than 6. If choice is greater than 6, it should stop. See, I have options from 1 through 5. So for 6, it is exit. So 6 or greater than 6, the program should stop. Let us run the program. Yeah, first it is asking for an array size. So I'll give the array size as 10. Now there is nothing in an array. First of all, I should insert few values. So first option I will take, that is insert. The value that I want to insert is 2 and the index should be 0. I will insert one more value. The value I want to insert is 3 and the index should be 1. Let us display, I should get two values, that is 2 and 3. Yes, 2 and 3 are there in an array. I want to insert one more value. Element is 15 and index is 0. Let us display. Yes, 15 is inserted at index 0. I will insert one more element, that is 10 at index 3. Let us display the elements. Yes, I got it. Then I want to delete an element. I have taken index 0. Let us display the array. Yes, value 15 that was in the beginning at index 0, that is deleted. Let us call sum of all these elements. I should get 15. Yes, it is working perfect. So in this way you can try out all the options and you can go on inserting and deleting the elements, and you can use menu options and test whether your program is perfect. All the functions are working in coordination or not. We have seen individual functions, but this menu driven program will help you to verify whether to confirm all the functions are coordinating properly or not. That's all with this menu driven program. In this video, I will show you how to convert a C language program into a C++ program. So already we have seen all the functions perform on an array. I will use that same code and I will transform it into a C++ class. Let us go next. And this is array CPP. Project name I am giving it as array CPP. And the language I will select it as C++. Next, it's created. And this is the main function. I'll copy the complete program what we have written for C language. That same program I will copy it here and I will modify it to make it as a C++ program. So I will remove this main function. I will copy and paste that program here. Yes, I have a complete C language program we have written. I'll explain you this program first. See, we have defined this structure for an array containing a pointer for pointing on an array, dynamic array, and the size and the length. These are the data members of a structure array. Then we have written various functions on this array. All those function prototypes are available here. I have written their prototype, and followed by that these functions definitions are available. See, all these functions we have written, and finally I have written a main function at the end, that is menu driven main function I have written. Here is a main function. So the same program I am using it, I will modify it as a program for C++. So I will convert it into a class. So one important thing is C language programs are more related to the logic or the procedures. So already we have all these procedures. Then C++ is more related to designing or organizing the code. So the same code we will organize it using C++. So here I will start making changes. First of all, instead of struct, I will say class. This is a class array. And class array is having a pointer, that is definitely I need a pointer, and a size of an array and the length. Yes, we need all these things. And these are data members. So I should make them as private. All these are private. Then inside a class, we will have data members and the functions. And the functions, we usually make them as public. Yes, I made it public. And the first type of functions that we write is a constructor for an array. So I will write down a constructor function, that is non-parameterized constructor I will write. In this constructor, let us set the size of an array as minimum 10. So by default, the size of an array is 10. See, I don't have to use any membership operation now because this is inside a class only, so I can directly say size. And length is 0 initially because there are no elements. Then this array, I should create it dynamically. So I should say new int of size. So size already I have made it as 10. This is a non-parameterized constructor. And next, I will also write a parameterized constructor which will take size. So I will give the variable name as sz. And I will do all these things here also. Same thing I will do here. See, instead of 10, I have to set the size as sz. That's all. This is a parameterized constructor. Then also I should have a destructor. So I will write a destructor for an array because here we are using dynamic memory. So I should delete that memory, delete A. As it is an array, I should use subscript operator. That's all. Constructors and destructors are ready. Now I should write all these functions inside this class. So simply I will include the prototype of all these functions inside the class. So I will remove this closing bracket of a class. Watch it here. This I am removing. Now these functions are inside the class now. All these are class members. Then at the end here, end of all these functions, I'll give a closing bracket of a class. Yes, this is a closing bracket of a class. That's it. All these functions are inside the class now. All these are members of this class. Now I have to modify these functions, bring some changes in them. So I will change all these functions one by one. First, let us see display function. It is taking an array as an object of type structure. So it doesn't have to take because it is already there inside a class array. It can directly access these members. It doesn't need any parameter. So yes, it means all these function doesn't need any parameter. Yes, this doesn't need any parameter of type structure array that we were passing. We don't have to pass it. They can directly access it. Then coming to the swap function, see this swap function, we have written it for using them inside another function. So it is not available globally. So I will make this function as private. This is a local function. This is useful only within a class and is useful for other functions. So I will make it as private. It is inside the private block now. Then linear search, I don't have to send array. I should only send a key. Then the parameter for binary search, it doesn't need an array. It needs only a key. Then get function, this doesn't need any array as an object. So all these doesn't need array as a parameter. They need other parameters like set, we need the index and the value. Finding maximum, whose maximum? The same array's maximum. It is inside this array class only. This is inside this array class. Whose maximum? This array's maximum. So we don't have to pass any parameter as an array. So all these are removed. Now coming to merge, union and intersection, they are taking two parameters, but here it should take just one parameter. Second array it should take, so I don't have to write struct for that. Remove struct, and here also return type remove struct because it's a class. For a class you don't have to write a class or a struct anything there. Just a class name is sufficient. They all should take only one parameter. That is the second array. First array, it is itself. So I'll remove this first parameter. Yes, all these functions became members of a class. These are all members of a class now. So they can directly access this array. Now outside the class, I should implement all these functions. So for implementing all these functions, I should write down class name and scope resolution and the function name. This I should add it before every function. And the changes what I have done is this array object should be removed, right? Then when accessing, I should directly say length. I don't have to say arr dot. I don't have to say arr dot. That's all. This function is changed. I will change few functions. Rest of them you can do it by yourself. That is easy. Remove this array parameter because it's not taking, and scope resolution, this is belonging to a class. Then for length, don't say arr's length, just say length, and just say size because it is inside the class itself. And here don't say arr dot operator, we don't need anything. Then insert function doesn't need array object as parameter, and whatever the members are, it can access them directly because it's a member function now. Yes, I have modified this insert function by removing the array as parameter and directly accessing the members. I will do the same thing for rest of them also. I have modified all the functions. Now it's coming to merge function. Merge function, it's taking two parameters. So here I should remove only one parameter. Second parameter is mandatory because it's going to merge two arrays. First array is itself and the second array we have to pass it as parameter, and it need not be a call by address. Then here for creating an array, I should use new operator for creating an object. Say new array, and I will call the parameter as constructor. The merge array size should be same as length of a first array, that is this array itself, and the length of second array. This is the change. Now for accessing first array members, I don't have to use any operator, that is membership operator. For the second array, I should have membership operator. I made it by value, so it should be dot. It should not be an arrow. And for third array, it should be as it is. This I will remove. Then second array, it should be dot. Third array, it should be arrow because it's a pointer. I have taken a pointer. Then first array, I have modified it. Then this one, remove this membership. Then this is dot operator. This is also dot. Yes, so again this array should be removed and this should be dot, and don't have to set the size, already I have given the size. That's all. Now similarly I will modify union, intersection and difference also. Now coming to the main function, inside the main function I should create an array object, so I will make it as a pointer, and when I know the size, here I will create an array object by passing size as a parameter. So in this line, I'll be creating array object arr1 assign new array, and whatever the size is given here. Then inside the main function, I will take one more variable, that is as a z for the size. Then here when taking the array size, I should take as z, and dynamically I should create an object now. Arr1 assign new array of given size. Yes, that's it. I don't have to initialize anything. Now the menu options, if you look at, then every function I should call it with arr1 dot insert. I don't have to pass this array, but it has become a member, so I should say dot. So this array parameter I should remove, and here delete I should say arr1 dot. Then linear search arr1 dot. This array parameter that was passed should be removed. Then arr1 dot sum, and array parameter I should remove. Now sum came inside array1 object, right? So this is arr1 dot display. So that's all. I have modified everything inside the program. Now you can see that this has become a C++ program. So I have also changed the printf and scanf functions and made them as scene and couts. So completely C++ code. Now let us see, are there any errors, anything I missed? I have actually changed the preferences in this Xcode option, that is show live issues. I have checked this one. Now let us go through this. Let us run the program. Yeah, program is running. It's asking for the size of an array. I'll give the size as 10. Now first option, I will select insert an element. I want to insert a 3 at index 0. Then enter the choice. Once again, I will insert an element, that is 5 at index 1. Then I will display the elements. So you can see here that two elements are there in a list, that is in an array, that is 3 and 5. I'll insert few more elements. Insert 9 at index 2. Then once again insert 8 at index 0. Let us display this list. See, 8 is inserted in the beginning, that is at index 0. Then we have 3, 5 and 9. Here are the elements displayed. Now let us display 5. 5 is at index 2. So I will select the option, that is delete. Option is 2. Then index, I'll give it as 2. Then let us display the list once again. Now the list is 8, 3 and 9. 5 is gone. Let me call the function sum and see the result of adding all these numbers. Yes, sum is 20. That's it. So you can take the list. So that's it. Like this, you can create a menu and try all the operations of an array. I am trying only few operations here, though I have written a lot of operations inside a C++ class. This is how we have learned how to convert a C language program into C++ program. In this video, I will show you how to write a C++ class for an array from the scratch. So already C language program we have seen, we have developed various functions. I will develop few functions here in a C++ class, so you get the idea how to write a C++ program for the same thing. Once you know how to write down the procedures, then either you can develop a C program or you can make it as a C++ program. Choice is yours. It's not difficult to develop a C++ program. It's as easy as writing a C language program. So let us see how to write a C++ program, how to write a class for array. I'll give the project name as array class and the language selected is C++. Create a project. Now the project is ready. Let us go to main function. Here is main.cpp. Yeah, here is a main function. I'll remove these panels on the left and right side. Now only a main function is here. Now let us write a class for array. I'll write a class array. A class in C++ should have data members and member functions. So what are the data members we require for an array? We need an array for storing the elements and size and length. So data members, I will make them as private. So first of all, array For array, I will not make a fixed size array, but I will take it as a pointer so that I can dynamically create an array. The next is the size of an array that I want, and next is length, that is the number of elements that are present in an array. So if you look at these data members, these are the same data members of a structure in C program. Now we have written various functions in C program, so here also we will write them as member functions of an array class. And the member functions must be made as public, so I will make them as public. Now as this is a class, C++ class, it must have constructors and destructor. So first of all, I will write constructor and I will expand it here only. This is a non-parameterized constructor, and in this non-parameterized constructor we should create an array of some default size and set the default size. So I will first set the size of an array as 10, and the default array I will create it of size 10. So let us make an array of size 10. Then length, there are no elements initially, then it is a 0. Then next I will write down a parameterized constructor so that I should be able to create an array of desired size. So I will take the parameter as sz. Then first I will set the size as sz. Then also I will set the length 0 because there are no elements so far. Then I will create an array dynamically of size size. Already size sz is set in the size, so whatever the size is passed, that size array will be created. This is about a constructor. Then we should also have a destructor. Destructor should release resources. So any resource we are acquiring here, yes, we are dynamically creating an array in heap. So this array should be released. So let us write a destructor. Destructor should have a same name as class name, just prefix with tilde symbol. So here I will delete a dynamically created array, that is A. As it is an array, I should use subscript symbol. Now I will write few functions here. The functions already we have seen, like insert, delete, display, search, so on. So I will write down only 3 functions: insert, delete and display. So first of all, let us write a function for display. This is a display function. Now if you remember, in C language program we were passing array as a parameter to this function, but we don't have to do it here because this function is a part of this array class. It can access these members directly. Yes, so this doesn't require any parameter at all. The next is insert function. As per the C language, we have seen that insert function was taking 3 parameters: array and the index and the element. So here I will just take index and element. Then delete function will take just index and it will delete the element from that index and return it. So that's all, 3 functions I have written. And you can continue writing all other functions like search, reverse, merge, finding maximum, finding minimum, setting an element, getting an element. All the functions that we have seen you can implement similarly. Now the functions prototype looks similar to C language functions, except that they are not taking parameter as struct array, except everything will be same. So the procedures written inside these functions will also be same. So now I will implement these functions outside the class using scope resolution operator. So the first function that I am going to implement is display function. So this is a class name array, then this is a display, and this function is for display purpose. So I can directly declare a variable here in C++ for int I assign 0, I is less than length. So where is length? This length which is directly declared inside the class. So this length I can directly access. I is less than length, then I plus plus. Then I should use cout for displaying the elements, that is a of I, all the elements I should display, and I want spaces in between the elements, that's all. Then at the end, I should also have endl for the new line. Now here I am getting a error, that is cout is an undefined identifier. So here actually I should use namespaces using namespace std. Then I'm using a standard namespace, std namespace, so then I can use all the objects inside that namespace, so error is gone. Cout was giving error here, but now error is gone. This is a display function. Now let us write insert function. So for insert function, I should write class name and scope resolution, then insert is taking two parameters, that is index and the element that we want to insert. So the procedure we already know that we should check whether the index is valid or not. Index should be greater than or equal to 0 and index should be less than equal to length. It should not be beyond length. If it is from 0 to length, then it's a valid index, then we can insert an element at a given position. For inserting an element, I should start shifting the elements from the last element. I should start shifting the element from last element onward. So for that I will take I. I should start from length minus 1 because the last element it has index length minus 1. Then I should continue until I reaches index and always say I minus minus. Then at a of I plus 1 I should copy the element from a of I. Means I should shift the element to a next place. This goes on in for loop. Then after shifting all the elements, at the index place, I should copy an element x. Then after that, I should also increase the length because a new element is inserted now. That's all with insert function. Now let us write a delete function. For that, I will write class name, scope resolution, then delete. It takes index as parameter. Now inside this delete function, I should check whether the index given is valid or not. So index should be greater than or equal to 0 and index should be less than length. If it is valid, then we can delete it. So for deletion, I should have one variable x that is initialized to 0. In this variable, I'll take the value. So first step is take the value from array at a given index. Then after taking the value, I should shift all the elements. Then for loop, I start from index onwards and I should stop at length minus 1 I plus plus. And here at a of I should copy an element from a of I plus 1. And after doing this, I should also reduce length, length minus minus, and finally return the element that is deleted. That's all. These are the functions I have written. Now I will develop a main function. I will remove this. Now inside the main function, you can make it as a menu driven function also, but I will write it as a simple function. First of all, I will create an array object ARR of size 10. I'll take the same size 10. Then here I will insert few elements and then delete the element. So first of all, ARR dot insert index 0 and element 5. So first I am giving index, then I am giving element 5. Then ARR dot insert, I will give the index next index, that is value 6. Then ARR dot insert, I'll give an element at index 2, that is 9. Now let us display the element. So I should use object name, that is ARR, and call function display, ARR dot display. Let us run the program till here and see. I should get the elements 5, 6 and 9. Yes, I got the elements that are 5, 6 and 9. The elements are displayed. They are properly inserted. Now after this, let us try to delete an element. So whatever the element is deleted, I will try to display that element ARR dot delete, and I will delete an element from index 0. So 5 should be deleted. And then endl for the new line. Again I will display the elements. I should get remaining elements, that is 6 and 9. Let us try this. See, first 5, 6, 9 were the elements, then 5 was deleted, then the remaining elements are 6 and 9. That's all. This is working. I have tried a few functions, I have written few functions and I have tried them. Now the very interesting thing, that this array what we have created is only of type integer. If I want a float type array, then I should write a separate class. No, instead of writing a separate class, it's possible to make a generic array in C++. So for creating generic arrays, we can create template. So template class T, instead of this integer type array, we can make it as T. Now I will show you how we can write a template class. So the class we have written, I will convert it into a template class. It's very easy. Once you have a complete class ready with you, you can easily convert it into a template. So let us do it. So on the top, I have written template class T before the class, and inside the class, wherever I want to make a generic data type, I should write T there. Now inside this constructor, an array is created of type integer, let us say T. And here inside the parameterized constructor, this also is T. Then these are display function. Now the element that I am going to insert, that should also be T. And the delete function will delete an element and return the value, so this should also be a T. Now the class ends here, so also a template ends here. The effect of this template has finished at the end of a class. Now when we are implementing functions outside the class using scope resolution, then for each function we should write down template class T, and we should use this template. See, first of all, the important thing is the class is template type, so I should write T here. Then inside this function, nothing is template. Then for this function also, I should write template class T. And first of all, I should make this class name as a T. I should pass the parameter as T for this class name. And the X value, the element that we are taking, is of type T. That's it. Inside the function, there is nothing like template. Now here, for delete function also, I should write down template class T. For each function we must write down, and the class name we should pass T as a parameter, and also change the data members if they are supposed to be template type. Like delete function is going to return template type, and this X is also a template type. That's all, everything is ready. Inside the main function, when I am creating an object of type array here in this line, I should mention the data type now. Now I am going to use it, and it's going to be integer type array. That's all. See, it was so simple. I have converted a complete class into a template class. So if you don't know this and you want to practice this, then you can watch it again and do it by yourself simultaneously. I will run the program and show you. Yes, program works successfully, the same results we got. Now let us try to take different data type here. Instead of integer, let us take float. And the values, what I will write here is 5.2 and 6.4 and 9.1. Let us see whether it works or not. Yes, it is working. 5.2, 6.4, 9.1. And the element at index 0 was 5.2, that was deleted. Then the remaining elements are 6.4 and 9.1. Now you can take any data type and you can implement this array. So I will change this data type to a character, then I will take few characters. See, first character is A, and second character is C, and the third character is D. Now A, C, D are inserted, then A will be deleted. Yes, it's working. A, C, D are inserted, then A is deleted, then C and D are remaining. So that's all with the C++ program. I have shown you Few functions, remaining function is a student exercise. You complete all the remaining function. The procedures are same as what we have learned on the whiteboard. Only the way we write the code, the style of writing the code is different. And it's not major different from C program. It's almost similar to C program. Practice this program. That's all. In this video, we will learn how to find out a missing element in a sequence of elements if the elements are stored in an array. First of all, I will show you how to find a single missing element in a sorted array if the array is already sorted. Then, if there are multiple elements that are missing in a sorted array, we will find out that. And next, if the array is not sorted, how to find the missing element. If there are one or more elements, we'll find that. So let us start with the first one, finding a single missing element in a sorted array. So here I have an example array with sequence of elements, and these are actually first n natural numbers. So the sequence is starting from 1 onwards. So if you see the elements 1, 2, 3, 4, 5, 6, then 7 is missing in this one, then 8, 9, 10, 11, 12. Up to 12 I have taken some numbers. Now I have to find out that one number, that is 8, is missing in the sequence of first n natural numbers. So what should be the procedure? So there can be more than one possible solutions. So let us look at first solution or first method. Sum of first n natural numbers. There is a formula for first n natural numbers, that is n into n plus 1 by 2. So if I have total 12 elements, so that is the last element, I should know already what is the last element, then sum of first 12 natural numbers, this can be known by using this formula. So I can use the formula. If I know the first number is 1 and the last number is 12, and I want to know which number is missing, then I can use this formula. So for example, for this 12, if I take it as 12, 12 into 13 by 2 is 2, 6, 6 3s 18, 6 1, 78. So the total should be 78. If total is not 78, if it is less, how much less it is, that is a missing element. So what I should do? I should find the sum of all these numbers. So finding the sum of all the elements in an array, that I can do it iteratively or recursively. So let me write down a piece of program code for doing it iteratively. So for finding sum of all the elements, I'll take one variable, that is sum, and initially it is 0. Then using a for loop, I can scan through this array from the first to the last index, that is 10. So for I assign 0, so I assign 0, I is starting from 1 onwards, and I should stop at 10. So I should say I is less than 11, I plus plus. So I should know the last index, that is 10. So till I less than 11. So what I have to do, sum assign sum plus a of I. Add all the elements from an array. Then here I'll be getting the sum of all these elements. Then I know the formula. Using the formula, if I know the last number, that is 12, so using the formula I can calculate that. So let us say this is n, this is n. So I can find s as n into n plus 1 by 2. So this will give me s, that is sum of first 12 natural numbers. So this should be 12. And this is number of elements in an array. Then once I got this one, then I can know the missing number from s minus sum. S is obtained from the formula, that is sum of natural numbers. I got it from the formula. Then minus a sum, that I have added all these elements. If I subtract them, then I get the number. For example, if I add all these numbers, it's like this is 10 plus these two, 20, these two, 30, these two, 40, and this is 48. Then these two numbers, 59, 71. So total I am getting 71. So this sum will be giving me 71, and for this just now I have calculated that was 78. So 78 minus 71 is a 7. So by subtracting this I can get the number. So directly I can print it here. So I will say printf missing number is s minus sum. So that's it. This is the method. You can find it using the sum of first and natural number formula. This is one approach I have shown you. Then I'll show you one more example where the elements are not first and natural numbers. The sequence may be starting from any point. So let me change these elements, then we will discuss about it. Now here I have array of elements. Now here the starting number is 6. It is not first and natural number, and the last number is 17. So first of all I should know what is the starting number and what is the last number, right? And in this one of the element is missing. And these elements are already sorted and one of the element is missing. So I'll show you which element is missing. 6, 7, 8, 9, 10, 11, 12 is missing in this one. So there is a sequence of sorted elements. I should know the starting number and the ending number, and I want to know which number is missing in this one. And the total number of numbers are 11, that is 0 to this. So let us see how to find out this one. So for that I will show you first of all, this is lower number, that is 6, and this is higher number, that is 17, and the total number of numbers I have, let us call them as n, and let us say these are 11 numbers, 0 to 10. Now from this 6 to 17 I want to know which number is missing. So I'll show you the procedure. See, the procedure is, if you take the indices, you can easily find out which number is missing. So here indices can help us. See, the difference between the first element and the index is 6 minus 0 is 6. Next number and its index, 7 minus 1 is 6. So 8 minus 2 is 6. So every number, if I take the difference, it is 6. Difference is 6. 11 minus 5, that is also 6. Then 13 minus 6. 13 minus 6 is not 6, it is 7. Oh, so here actually I should have got the difference as 6, but I am getting a difference as 7, means this element is missing. Yes, what should be the element? See, we know the difference was 6, right? So we are at index, which index now? We are at index 6. So in that you add 6 plus 6 you add, that is the difference, so you get the number 12. So that is number 12 is missing. We know the difference is 6 and we are at index 6 right now. So these two 6 are same right now. So 6 is the index and the 6 is the difference. So in this way I can continue checking, and from this point onwards the difference is 7. So I should make sure that the difference is 7. So if you are sure that there is only one element missing, we can stop here because the missing element is found. And if the procedure is for finding multiple missing elements, then I can continue till end. So here I will write on the, so the procedure is, we have to scan through this array checking the difference. If the difference is always same, if there is a change in the difference, means element is missing. So with the help of indices we can find out. So for this we have to scan through this array. So I will write on a piece of code for scanning through an array and finding missing element. Now for writing the code I should already know these things, that is low, high and number of elements. So let us take this. We know that the array index starts from 0 onwards. So first of all, I will take difference. Difference is low minus 0. That is low only. Low minus 0 gives me the difference. So 0 I am writing so that I can show that this is difference. So starting index and this difference, it will be 6. Now using a for loop I can scan through an array, and every time I should check that the difference maintained is 6 only. So for I starts from 0 and up to n, that is less than 11, that is last index 10. What I should do every time? I should check that if for every element, if the difference is not 6. So difference of an element a of I minus I, if it is not equal to difference. If difference is not matching, then the missing element is found. So I should print this one,
missing element is index plus difference. Index plus difference. So index is I here, so it should be I plus difference. That's it. So that's it. Missing element is found, then I can break and stop end of this loop. So this break will come out of this for loop and it will stop there because the missing element is found. So that's all. This is for single missing element. Now one thing. What is the time taken for finding missing element? So we have finished finding single missing element. What is the time taken for this one? So the time depends on the amount of work we are doing. So what is the work we are doing? We are scanning through the elements in an array. How many elements are there? Some elements are there. What is that sum? N. N elements are there. So how many times we are scanning through? We are scanning through only once. So the time is order of N. Order of N. Right? So order of means degree. What is big O, theta, omega? That's all different thing. So we don't need all those. So it's order of N. Yes. So the time taken for finding a missing element in an array is order of N. Now next, I'll show you how to modify the same code for finding the next missing element in an array. So I will change some elements here. Then we will find multiple missing elements. Now I have more than one missing elements in an array. Let us look at the elements first. 6, 7, 8, 9, 10 is missing. 11, 12, 13, 14 is missing. Then I have 15, 16, 17, 18 and 19. So more than one elements are missing. And also from 12 to 15, if you see, continuously two elements are missing. So I have taken both the cases, that is one or more elements are missing and also continuously more than one elements are missing together. So let us see how we can find out this one. So we will follow the same logic that I have shown here by taking the difference of index and the element. So let us start how we have to modify the logic here. See, let us start from here. The difference is 6, right? 6 minus 0, difference is 6. So difference is 6. And here difference is 6. So element is not missing. Difference is 6, element is not missing. Difference is 6, element is not missing. Difference is 7. So element is missing. What is that element? Difference is 6 and the index is 4. So the missing element is 10. But the new difference is 7. Yes. So I can know the missing element by taking the index as well as the difference. So I'll get the number 10. So 10 is missing. And now from here, missing element onwards, the difference has changed. That is 11 minus 4 is 7. So this is 7. Okay, continue. Next, difference is 7. Okay, continue. No problem. Now difference is 9. Oh, so two elements are missing. So previous difference was 7 and the new difference is 9. So how many elements are missing? So right now we are at index 6. So difference was 7. 7 plus 6, that is 13. 13 is missing. And also 8 plus 6 I should take, that is 14. Then 9, oh, I should stop because the difference is 9. I should stop. So I got two elements missing. So I should start from 7, difference 7 and also difference 8. Difference 9, stop because the difference is 9 and we have that element. So for displaying multiple elements, I have to do multiple elements. So again, it means I should use a loop here. Yes. Then next, let us continue further. The difference is 9 and the difference is 9 and the difference is 9 and the difference is 9. So that's all. Everything is perfect. So we have found three missing elements, that is 10 and 13 and 14. So logic will be similar. I should take a difference and scan through. Wherever the difference is not matching, the element is missing. So let me write on the code here. So this is the workout I have done. So I'll put it in a box. I will write on the code freshly. See, first of all, we have taken difference. Difference is starting element, that is lower number, 6. 6 minus 0, this is the difference. And what I have to do, I have to scan through this array. So, okay, for loop, for I takes values from 0 onwards and I should be less than equal to 10. So that is less than 11, less than n and I plus plus. Then Every time I should check that whether the difference between the element is maintained, same difference is maintained. So index versus element. So if element at I and I itself, if we take a difference, if it is not equal to the starting difference, this one, if it is not equal, means there is some element missing, right? Now this difference may be of 1 or maybe of 2 or maybe of more. See, in this example the difference was 1, new difference was 1. Now in this example new difference is more than 1. So I assume that it may be 1 or more than 1. So let us say more than 1 only. So for that I will display all the elements. So how to display all the elements? The current difference plus index, right? So that is 5, the current difference plus index. Right now here I got a mismatch, for example. So this is 13. If you add this 13, then make it as 8, then this will give you 14. Then make it as 9, so it has become equal. So stop. So I should start from the current index to the new index. So if it is not equal, current difference, right now whatever the difference is less than the new difference a of I minus 1. See, this is the new difference and this is the existing difference right now. And if this new difference is not equal, then the element is missing. So while this is not equal, what I should do? I should print the element. So directly I am printing the element. Printf, the element is current index plus difference. And I should move to next difference. So difference plus plus. That's it. So using a loop, I will print all the missing elements. Present difference plus index, that is present difference. Right now, present difference is 7 plus index is 6, right? So I'll get 13. Then difference plus plus. Now the new difference is 8 plus index 6, 14. Then difference plus plus. Difference become 9 and this difference is 9. It is 9. So it will stop. Now the difference has modified. Again, the same loop will continue. That's all. So if there are multiple elements missing continuously, for them I have to write a loop here. So using a loop I am printing rest of the elements. So this is the method for finding missing elements in a sequence of elements, and the elements must be sorted. Now how much time it is taking? See, what is the amount of work we are doing? We are scanning through the list of elements. How many times? Only one time. So the time is order of n. So if there are n elements, so the time is order of n. So if you look from the code, for loop is there. For loop, how many times it will repeat? N times. So time is order of n. But what about this? What about this? See, I am printing missing elements. How many? Will it be printing all n elements? No, just a few elements. So it's negligible. So overall, if you see, the number of time the process is done is from 6 to last number 19. So this loop will repeat from 6 to 19, and this loop will print the missing element. So 10 is missing, so that is printed. 13, 14 is missing, so that is printed. So those elements are also included. So without missing all the elements, so this loop is accessing all the elements, missing any element. So it means we don't have to consider the time taken by this loop because this time is negligible. Just it is filling up the gaps, that is missing elements. So the total time is order of n. So time taken by this algorithm is order of n. So that's all. This is the method how to find a missing element, one element or multiple elements in a sorted array, and the sequence of elements may be starting from 1 onwards, may be starting from any other number. So this procedure I have shown you, this you have to write down the program and execute it. So you can write a main function, and in that you can declare an array, and inside the main function only you can write down this logic and check it. So this is a student exercise. In the next video I will show you how to find a missing element in a unsorted array. Now let us see another method which may be a faster method for finding missing element in sequence of elements. So the same example, I have set of elements that are starting from 1 and ending at 12. So 1 to 12, and some elements are missing that are 5 and 8. We already know that. And the previous method was taking order of n square time. Now for making it faster, I have taken an array here. That is array from 0 to 12. The last index is h is 12, so the maximum element is 12, so I have taken an array till 12. So first of all, take an array equal to the size, that is the maximum element you have in the sequence. Then initialize the array with 0. Okay, initialize. Now what to do with this? I'll show you the procedure. See, scan through this array one by one. Now let us see the procedure. See, scan through this single dimension array, taking one element at a time. What to do for each element? First element is 3. Go to index 3 and increment it. Make it as 1. So it was 0, just make it as 1. Then next 7. Go to index 7 and make it as 1. Increment it. 4. Go to index, then increment it. 9. Go to index 9 and increment it. Go to index 12 and increment it. Then go to index 6. Same thing. 1. Increment. 11. Increment. Then 2. Okay, increment. Then 10. Increment. So I have scanned through this array, and for that particular element I have gone into the same index. Like for 11 I went into index 11 and incremented that value. So now in this array I have all those location marked as 1 for the elements that are present in an array, and the missing element, they have still zeros, like 0 0 0. Anyway, this 0 is not there in our sequence. Our sequence starts from 1 onwards, so ignore that one. So from that point, from 1 to 12, if you see, there are 2 places that are still zeros, means the elements are missing. So this procedure looks simple and faster. Yes, what is the work we have done? Let us analyze the time, then I will show you the code. So first let us analyze the time. So the time taken is, we are scanning the list of elements. Yes, then for every element what we are doing here, at the same index we are incrementing it. So how much time it takes for incrementing it at the same index? Constant time, because I don't have to search anything. Like if it is 1, go to index 1 and increment it. Like if it is 12, go to index 12 and increment it. So the time taken is constant. So majorly where the time is spent, we are scanning through this list of elements, so that is order of n. So yes, the time taken is order of n. So this is the faster method. Yes, this is the faster method. Now this is one of the suggestion which is faster. Now one more thing in analysis. What do you call to this such an array? Now one more thing in analysis. What do you call to this array? See, I have given a name as h. So usually this is hash table. Hash table, we'll learn it later, but the simple implementation of hash table, hash we are saying because whatever the element is, we are going to that same index and accessing it. So this takes constant time. Remember that hash table takes constant time, that is ideal time for hashing is constant. So this is taking constant time for storing those elements here, right? So this is hash table, or else we can call it as bit set. So we are taking the set of bits for each number and we are marking them, and whichever are zeros, those elements are missing. Yes, this bit set, we have not implemented the complete mechanism of hashing technique, like using a hash function, all those things, but this is the simplest form of hashing. Remember, whenever you have to search, you can apply hashing if possible. Then one important thing about hashing, when you are using this array as a hash table and storing the elements, then you need an array space equal to the largest element. So it is 1 to. So this may take a lot of space. So space, if it is a constraint, then you cannot use this hashing. Means if you have limited space, then you cannot think of hashing. But nowadays the machines that we are using, they have abundant memory space, so we hardly bother about memory space. So hashing is a best solution whenever you are searching something. So yes, we have used hashing and reduced the time. See, remember in the previous method the time was order of n square, now it has reduced to order of n. It's a big change. And using this approach, you can solve various problems. So this you can take it as a basic idea, not just a solution to a problem. Now I will write down a piece of program code and I will explain. See, for writing a program, first of all, I must have array of elements, list of elements, starting index and the ending index and the number of elements. And also I should have an array. Dynamically, you can declare an array of that given maximum size and you can initialize it with 0. So assume that that part is already there. Just I will scan through this list. So for scanning through this array, I will take a for loop for I assign starting from 0 and I is less than number of elements that are n. So less than n, I plus plus. Then what I should do every time? See, if the number is a 3, a of I initially is 0. A of I is a 3. So I should go to index 3 and mark it as 1. So increment it. So a of I, which is 3. So I should go to that index in h. So h of a of I, that I should increment it. That's it. So it will scan through this array and for every element in that particular index, it will increment it. So this for loop will increment wherever the element is found. Then I have to scan through this array and find out missing element. Wherever is 0, that element is missing. Simple. So I will write on one more loop. This is over, right? After this, the next for loop for I assign, I should start from which element? This element to this element, that is low, and I is less than equal to high, I plus plus, right? So I should start from 1 and add 12. Then every time I should check if h of I is still 0, means element is not there. So simply I will printf. Which element? Like h of 5 is 0, so 5 is not there, right? So printf percentile d, new line, and I will say I. So that is index. So that's all. In a single line I have written it. So this for loop is for scanning through this array and this for loop is for scanning through this array. So this is also order of n, and this for loop also number of elements are n. Total it is 2n, so I can say it's order of n. Degree of a polynomial is n. So this for loop n times, so n elements, so 2n, and time is order of n. So that's it. So you can write down this program and check it. So you can directly write inside main function, and you can execute this program. So this is a student exercise, so you have to do this one. That's it. Now the next challenge is finding duplicate elements in an array. That is duplicate elements in a list. So in this video we'll be looking at finding duplicates in sorted array and also how to count those duplicate elements. So if you look at the example what I have taken here, 3, 6, 8, 8 is 2 times, 8 is duplicated, and 10, 12, 15, 15, 15, 15 is duplicated, and that is 3 times. So first I will show you how to find the duplicates, then also I will show you how to count them. So let us develop some procedures for finding duplicates and counting duplicates. Let us develop a procedure for finding duplicate elements in a list. So for finding duplicates, I should scan through this list. So total number of elements in the list are 10. So let us say I have number of elements that are 10. Now let us see what we have to do while scanning through a list. So I'll take a counter I and I will scan through the list. So let us take I. I is 0. So being here, I should check whether the next element is same as this one. So at a of I should check a of I plus 1. Is it same? These are same? No. So quietly move ahead. Then, is it same? The next element is same. Now I is at 1. Check the element at next location. No, it's not same. So move ahead. Now, is it same? Yes. So a duplicate is found. So wherever I is pointing right now, there is a duplicate element. That is, that element itself is duplicate. So okay, display 8. Then move on to the next element. So now here, again check the next element. See, being on one element, we are checking the next element. Is it the same element? No, it's not duplicate. Then is it the same element? No, it's not a duplicate. Is it the same element? No. Is it the same element? Yes. So 15 is found, so we can print 15, that is duplicate element. and move next. Now see the difference here. If I move next and again check the next element, being here if I check the next element, it is same. So it is again 15. So shall I print 15 once more? No. So I should print 15 only one time. Right? So this I have to take care. If a same number is duplicated more than 2 times, then I have to take care of that situation also. So here it is duplicated more than 2 times. So let us see what I should do. So I'll again start the procedure and see how we can proceed for this one. I'll take one variable here. Let us call it as last duplicate. Last duplicate, initially let it be something, let us say 0. Now let us start once more. See, for this problem, handling this problem, we are using this one. Now, same procedure. Next element, is it same? No, it's not a duplicate. Next element, is it same? No, it's not a duplicate. Next element, is it same? Yes, we got a duplicate. So last duplicate, I'll remove this 0 and keep it as 8. So check the last duplicate. Last duplicate, is it same? No, this is 0. So this is a new duplicate we got. So print this 8 and change it to 8 and move to the next element. Now check the next element. Is it same? No, it's not a duplicate. Next, not a duplicate. Next, not a duplicate. Now being here, 15. So next element, yes, 15, it's a duplicate. Is it the same one that we found it at the last? No. So print that 15 and change it to 15 now. Change it to 15 and move to the next element. Now, again next element is duplicate. But is it the same element last duplicate we found? Yes. No need to print. So if that same duplicate is there, don't print it. So that's how. Just you can maintain one variable to keep record of last duplicate found. That will help you if there are multiple occurrences of duplicate element. So that's all. This is the procedure. So that's it. This is the procedure. Now let us write the program code for it. I will take one variable called last duplicate and let us set it as 0. Now I have to scan through this array, so that I can do it using for loop. So this for loop will take me through all these elements in an array. Then every time what I should do, being on one index, I should check whether the next element is same. If it is the same, then I got a duplicate. So check if a of I is equal to a of I plus 1. So if these are same, I should check that. And also I should check that it should not be equal to that duplicate, and a of I is not equal to last duplicate. So if these two conditions are true, then I got a new duplicate, so I will print this one. So printf print an element at a of I and also modify last duplicate to this a of I. So that's all. This is the procedure. So if the next element is same and it is not same as last duplicate, then it will be printed and we will record this new duplicate so that we don't print the same thing next time. So that's all. This is a student exercise. So you can write on this program just as a part of main function. You can do it. You can take an array of these elements and you can write the rest of the code and you can check what the results you get. So it should print the duplicate elements. Now next I will show you how to count the number of duplicates. Like 8 is appearing 2 times and 15 is appearing 3 times. So let us see how we can count this. Now let us see how to count. The procedure will be same as finding duplicate. Just now we saw the procedure, but only the difference is we also have to count how many times it is appearing. So let me devise a procedure. Let us check. So I will scan through this list of elements one by one and the procedure is same. I will be checking whether the next element is same. No, it's not same, so it's not a duplicate. Next element, is it same? No, it's not same, so it's not a duplicate. Next element, yes, it is same. Yes, it is same. So once you got a new element, so once we got a duplicate element, what we can do is we can count how many times it's appearing. So we can continue counting from there. So what I will do is next element I will keep it as j, that is another counter. That is for counting. And keeping it as j, I will check whether this is same as this one or not. Yes, it is same. Then j plus plus, is it same as this ith element or not? No, this is not same. This is different. So stop. We got the number of duplicates. How many? See, j is 4 and I is 2. So 4 minus 2 is 2. So we got 2 duplicates. Now once we have finished this counting, I should move to this element, that is I should move to this location, that is j minus 1. So from here I can continue smoothly, because next in a loop it will be I plus plus and it will automatically go to the next element. So let us continue the procedure. This is over, right? Now again continue. Is it same? No, not same. Next, is it same? No, not same. Is it same? No, not same. Is it same? Yes. So when it is same, again you can start j from here and go on incrementing j. Is it same as a of I? Is it same as a of I? Yes, it is same. So j plus plus. Is it same as a of I? No. So from I to j we have the duplicate element. So what is the element? That is 15. How many times? So j is 9. 9 minus 6, that is 3. So 15 is appearing 3 times. Then bring I here and check if next element is same. No, it's not same. So I, when it reaches the last index, it should stop. So in the for loop I should say n minus 1. I should not go up to n. We are using two indices, I as well as j. I am using simple names, that is I and j is helping us to count. So let us write down the code for counting. So the code will be similar to the duplicates code, just here we are counting with the help of j. So I will write down the code. So for scanning through the list of elements, I need a for loop. So for will start, I will start from 0, I should less than n minus 1, right? So in the previous example, I wrote n here, it should be n minus 1, means the last position is here, I should stop here. Beyond this, there are no elements. Then I plus plus. Then what I should do? See, when I is here, I should see that if the next element is same. So yes, same thing, if a of I is equal to the next element, that is a of I plus 1. If it is same, then what I should do? I should start j from here. I can start from here and make it move until it finds a different element. So j should stop here. So inside this, I can say j assign I, or I plus 1 also I can write. And I should move j while a of j is equal to a of I. As long as it is equal, I should go on moving j. So say just j plus plus. So here I have not written any brackets or anything. This is a part of while loop, right? In a single line I am writing it. Then once j stop at some place like here, then the difference between these two is the number of times 8 is duplicated. So I can print this one. Printf. I will print the duplicate element and the number of times. See, percentile d is appearing percentile d times. So who is appearing how many times? J minus I times. J minus I times. Then after this, I should make I come onto this location, not on. Now after this, I should move I to a location just before j, because in a loop, again, I plus plus, I will be definitely moving. So I should be j minus 1. That's all. I is used in the for loop. Can we modify it inside the for loop? Yes, you can modify it. So now already these two elements are finished. So I was here, so I can bring I here. So next time I plus plus, again I starts from this point. Now again it will check this element with this one and this with this one, so on. So that's all. So just by using a j variable, I am counting the number of elements. Now next thing is analysis. I want to know how much time this procedure is taking. So what we are doing in this one? We are scanning through all the list of elements. How many times? Only one time. We are scanning from left to right. See this for loop. Even in the duplicates, displaying duplicates as well as counting duplicates, the logic is same. Only difference is we also have one more while loop inside. Then, do we consider this while loop? No need. No need. Is it covering the entire array? No, just a part of an array. Part of an array. so it's negligible. And even when we have moved j to some location, we are also shifting I. So those elements, whichever elements we have covered, so the elements covered by j, we are skipping it I, so we don't have to count it. So this loop is negligible. Though while loop is there, it's not doing extra efforts. So the time is equal to the number of elements, that is number of elements we can say n, order of n. So the time is order of n. So this is the analysis for finding duplicates and counting duplicates. Now next I will show you one more method, that is using hash table. We can find duplicates and also count duplicates. So let us see another method. Now let us look at a second procedure for finding duplicates in a sorted array. Already I have a sorted array and there are some duplicate elements like 8 is duplicated and 15 is duplicated. We want to know how many duplicates are there, and also we want to know count. Like if 8 is duplicated, how many times it is duplicated? If 15 is duplicated, then how many times it is duplicated? Now for this second method, I am using hash table. So this is the simple form of hash table, right? Though we don't know what is hashing, we have it in the last section, but just we are using a simple form of it. So this is an array actually, and the array size is 20. Why I have taken array size as 20? Because the largest element in this array is 20. So just you can go at the end of a list, because it's a sorted, so the last element gives you the size of this array. We should have an array equal to that size. So if it is 20, I must have an index 20, remember this. So I should create an array of size 21, right? Then I get the starting index as 0 and the last index as 20. Then next, this should be filled with zeros. Yes. Then what is the procedure? Let us look at the procedure. So let us scan through this array by taking one element at a time. So for that, I will take a index pointer, that is I, starting from here. Now while scanning, check the element. Element is 3. So here, go to index 3 and mark it as 1. Increment it, right? Then move I to the next element, go to index 6 and mark it as 1. See, going to the index 6 and mark it as 1 takes just constant time. I have to say h of 6 plus plus. That's it. It's simple. Then go to the next element, 8, mark it as 1, increment it, right? The next, increment it. So actually this was 0, so I have marked as 1. Now again 8 means make it as 2, increment it. Then 10, increment this one. Then 12, increment this one. 15, increment. So again 15, so make it as 2. Again 15, so make it as 3. So finally I wrote 3. Then 20, make it as 1, increment it. So scan through this array of n elements once and mark these or increment the count, right? So now in the hash table you can find that which element is appearing for how many times. So here we got the results. Now before showing in the code, let us do some analysis. How much work we are doing? We are doing nothing but scanning through this array. So how much? N, right? Then how many times? Only one time we are scanning. Then where is the result? And while scanning, we are marking this, that is incrementing the counts. How much time this is taking? Like for 10, I directly went to index 10 and I have incremented. Like for 15, I directly went to index 15 and incremented. So incrementing this take constant time, constant time. So what is the major time we have spent? N, accessing this one. Then next what we have done? We have to find out what are the duplicate elements from this hash table. So we can scan through this one. This is not there, not there. This is one time. Okay, one time. This is 2 times. Then this is 3 times. So I have to scan through this array also. How much time it takes? Plus n. How it is n? See, that are only 10 elements. These are 21 elements. So 10 means here not count. See, when we say n is the size of the input, n means size of the input to an algorithm, right? So in this procedure, n is the size. Okay, whose size? This size or this size? Whatever it may be. We are not bothered about exact figures. Here, now listen carefully. N means linear. Yes. Then what about this? Linear only. So what I should say? N only. If you say no, this is larger, okay, you take it as 2 times of n, no problem. No, still larger. So whatever you want, you write on k of n. So this is also linear. Then if I take it as only n, then I say 2n. So what is 2n? 2n is also linear, right? So finally it is order of n. Yes, it takes order of n time. So this is the analysis. Now I will write on the procedure and show you how we can mark these elements or count them and also display the result. So the procedure is I have to scan through this array. So for that I will take a for loop. For I assign 0, I should go till n, suppose number of elements are n, then I plus plus. Then for each element, like a of I is what? 3. So for a of I, right, a of I means let us say 3. So I should go to third index. So that is h of a of I. Yes, a of I is 3. So that 3 I should find the index here, right? So h of 3 plus plus, this will increment. So that's all. This is how I can mark them or increment them. This is over. Now the next step is go through this hash table array, and wherever we have count more than 1, print the element. So here for loop once again. For again I will take I. See, this is not inside this for loop, this is independent for loop, right? For I assign 0, I is less than whatever the maximum number is. So less than, or I is less than or equal to whatever the maximum number is. Like here we have maximum is 20, so up to 20, and I plus plus. What we should do every time, if that value here, the value is greater than 1, if h of I is greater than 1, then we will print. So in the same line I will write on printf. Here printf percentile d I gives the number and h of I gives the count, how many times it is appearing. That's it. It's a simple procedure. Let us do the analysis. See, this for loop is repeating for some number of times, so it is n. And this is independent for loop. It's not a part of that one. See, this for loop was n. Now this is independent for loop, and it's also repeating for some number of times, so it is n. So when you have a single for loop, it is n. If you have for loop inside for loop, then it's n square. So this is n plus n. So this is 2n, and time is order of n, right? Or big O of n. So the time is order of n or big O of n. So we have done the analysis from the code also. So that's all. Finding duplicates and counting how many times it is duplicated. You can write on this procedure. You can write a simple program, take an array and one more array for hash table, and write on this code and see, right? So it's a student exercise. That's it. In this video, we'll look at a procedure for finding duplicates in an unsorted array. I have an example array. Here the elements are not sorted, and there are some duplicate elements present here in this array. Like 8 is appearing 2 times, and 6 is appearing 3 times, and the rest of the elements are unique. Now I want to write a procedure, find out duplicate elements, and also I want to count them, how many duplicates are there. So there can be more than one solutions. So first solution let us look at. We will scan through an array, we'll pick up an element and look for its duplicate. Like 8, we will check in the rest of the array and find out is there any other 8 present in an array. Next we'll pick up 3 and check in the rest of the array to find if there is any other 3 present in an array. So I will demonstrate in this list. So for demonstration, let us take one variable, count, and initially let us say count is 1. Now start from here. This element I am counting it for 1 time. Now from here I should check in the rest of the list, is there any other 8? So for that I can take one more variable, that is j. With the help of this variable I will scan through this list and find out if there is any other 8. So let us start. Is it 8? No. Move j to next location. Is it 8? No. Is it 8? Is it 8? No. No. Yes, it is found. So once it is found, 1 to this. So now we have 2 8s. Continue. So is it 8? Is it 8? No. So we have finished looking for a duplicate of first element 8 and we found two elements. So count is 2 means yes, there are duplicates. Already we have taken that 8 into count. So we should not count it again. It may happen that the same element is counted multiple times. So we will see that situation. So for that, we should remove that 8 or we should have some marking to show that that is already counted. So for that, I will take -1 in this place. So whenever a duplicate is found, just mark it as -1. -1 is element is not there. Alright. Now let us continue. We will find the duplicates of other element. Then I can explain you what is the reason of taking -1 once again. Now start. I will find the duplicates of next element 3. So make this as count as 1. Now using J, go on looking for 3. 3 is not there. Now take J from here and go on looking for the element 3 by comparing the elements next. So 3 is not there. So count remains 1 means there is only one copy of 3. Now let us take the next element 6. Now here I am at 6. Now start finding 6 using J. Is it 6? No, it's not 6. So move J to next. Is it 6? Yes. So count. Then again move to next. It's not 6. This is 6. So count. Then this is -1, leave it. It's not same. So this is 2, this is 7. I have came across 2 more 6. Right? I'm finding the duplicate for this one. So I should mark this as -1. Yes, -1. Now count is more than 1. So it means there are duplicates of 6. Next, let us go to the next element. For 4, if I find in the rest of the array, there is no other 4. So count remains 1 for 4. Now take the next element. Now the point is, shall I take this element or not? If I take this element, then again I will get the result that 6 is appearing 2 times. I should not take that element because already it is counted. Leave it. So it's a duplicate element. So I have marked the duplicate elements. Otherwise, I may be getting duplicate results. Otherwise, I will be getting extra results that for 6 it appear 3 times. Again from here 6 appear 2 times. So that is the reason I am marking them. So this is the procedure. Now before showing you the program code, let us do some analysis. How much work we are doing. See, we have started finding a duplicate element of 8 first here. So for finding duplicates, I am comparing with the rest of the elements. So if there are total n elements, then how many elements I am comparing? N-1 elements I am comparing. Then again, being on 3, I am comparing the rest of the elements, right? I don't have to check on this side. I have to check the rest of the elements. So total how many? N-2 elements I am comparing. Then being on 6, I am comparing N-3 elements. So N-3 comparisons I am performing. Then same way, it's go on reducing up to last 3 comparison, 2 comparison and 1 comparison. So these many comparisons I am doing. So total, how many comparisons are these? These are n into n-1 by 2. N into n-1 by 2. So this is n square minus n by 2. So the degree is n square. So it is order of n square or big O of n square. Though we don't know what is big omega. So let me call it as order of that. So I'll be simply calling it as order of, that is degree of 2, that is n square. Degree is 2. So it is order of n square. Right? Now let us look at the procedure. So I will write on the procedure for this one. For finding duplicate, I have to start finding the duplicates of the first element. So I should start from here. So one is I, that start from 0, and I should stop here because I don't have to check for the duplicates of this element. I should stop at this point at last. So that is less than n-1 I plus plus. Right? So this is the main loop that is going through all the elements to find their duplicates. Then every time I should start count with 1. Okay, count with 1. For every element, count as 1. Then find are there any more elements to increase the count. Now, when I is here, I have to scan through the rest of the list, right? So I am starting J from here and continuing till the last element. So I will take one more for loop for this J, that is J assign I plus 1, that is next element of I, and it should go till the last element, so it should be less than n and j plus plus. Then what I should do, like for 8, if I have reached here, means the element is matching. So I should compare this element with this one, and if they are matching, I should increment count. So here I will set if a of I is equal to a of j. If they are equal, then I should do count plus plus. Yes. Then, as I said, also I should mark this as minus 1. So at a of j, I should make it as minus 1. So count plus plus j minus 1. Then end of this loop. Now once I come out of this loop, I should check what is the value of count. If count is greater than 1, then means there are duplicates. So here I will write down printf if count is greater than 1, then print. So here I am printing percentile d. First is a of I, that is 8, and count means how many times it is duplicated. So this will print this one if count is greater than 1, means there is a duplicate element, and how many times it is duplicated, both I am getting. So end of this loop. Now one more thing, this checking for the duplicate I should do if it is not minus 1. So here I will write on the condition if a of I is not equal to minus 1. Means for this element I should not find the duplicates, right? Because already it has become minus 1. So for this one I should not do, right? I should not enter into this one. So this is conditional. So that's all. This is the procedure for finding duplicates and counting how many times each element is duplicated. Already we have done the analysis. Now let us look at the code and do the analysis. See, from the code, this loop is repeating for n minus 1 times, so almost n times. This will repeat for almost n time. And this is starting from I plus 1 till n. So this is also repeating almost for n times, right? We already know the working. Based on that we are saying that, right? It's not just by reading the code. We know the working. It's starting from I plus 1 till n. So this is also almost n times, right? Otherwise, if you want to consider in detail, this will be reducing one by one. N minus 1, n minus 2, n minus 3. So if I sum up, again it was becoming n square. So now roughly I am writing it as n. So this is n inside n. So there is a for loop inside for loop. So the time is n square. That is order of n square. So that's it. This is the procedure for finding duplicates. So you can try this by yourself. It's a student exercise. I have written the code on board. Just you have to write a main function, and inside the main function you have to declare this array and write down this similar code and see the results. Now let us look at the second method for finding duplicates and counting duplicates in a unsorted array. So this is using hash table, a simple hash table, or also you can call it as a bit set. So let us see the procedure. I have the same array here having duplicates, that is 8 is duplicated and 6 is duplicated. Now I have to take a hash table array, and the size of the array should be equal to the largest element in the array. So if you check in this array, the largest element is 8. So I have taken till index 8, means total size is 9, because starting from 0 onwards. Now the procedure is I should scan through this list, and for each element I should increment the count here in this hash table. So let us do it. Start from first element 8. Go to index 8 here and increment it. Then move to next element 3. So go to index 3 here, so increment it. And 6, go to index 6, yes, increment it. 4, increment it. 6 again, so 6 should be made as a 2, I'll overwrite it. Then 5 is 1. Then 6, I will overwrite this one. This is 3. Then 8, this is 2. Then 2, this is 1. And 7, so this is 1. That's all. I have scanned through this array only once. Yes. So if I analyze how much time I have spent, order of n time. So I'll just write n. Now next what I have to do, I have to scan through this hash table wherever I got a value that is greater than 0, yes, this is greater than 0, greater than 0, yes, wherever I get the value is greater than 0, element is present there. And if the value is greater than 1, then duplicate is present there. Like this is 1, so this is single value, 3 is single, 4 is single, 5 is single, 6 is appearing 3 times, right? 6 is appearing 3 times. And this is 7 is single and 2, so 8 is appearing 2 times. So I got the elements which are duplicate and also how many times they are duplicated. I got both of them. And for scanning through this, let us say time is n, because actually n means here linear. Actually n here means it's linear, right? Linear. So this is linear list of elements, whatever the size may be. Don't check that this number of elements are different, this is different. If that is n, this is n minus 1. No. N means linear in simple terms, right? So this is also linear. So linear plus linear is 2 linear. So 2 linear is also linear only. So it's order of n. So 2 times of linear is also linear. So I will not write down the code, right? So already we have seen this in missing elements. So logic will be similar. You can write down the code for this one. So this is also a student exercise. So you can write on the main function, in that you can take this array and then write on the code for finding duplicates and also displaying their counts. So that's it in this video. In this video, we'll learn about a problem, a challenge, that is, if a list of elements are given, then we have to find out a pair of elements, so that is 2 elements, such that their sum is equal to some given number. For example, we want 2 elements A and B such that their total is equal to 10. As per my example, I have taken 10. So we have to check in this array, are there any 2 elements whose sum is equal to 10? So let us check it directly. 6 is there. So I need 4 so that it becomes 10. Is there any 4? No. Then 3. I need 7 to get the total as 10. Check for 7. Yes, found. So we have a pair of elements, that is 3 and 7, which is forming total 10. Then 8. I need 2 for this one. So check for 2. Yes, found. So we have one more pair of elements whose sum is 10. Then 10. So already it's 10. So I should have 0. Check for 0 in this remaining list. No, 0 is not found. Now one thing, why I am not checking this side? See, this side already I have compared with the rest of the elements. Right? So I have to check forward only. So now 16, this is greater. So anyway, if I check, there is no pair found. So this is not equal to 10, there is no pair. If there is any number, it should be negative number, that is minus 6, right? Then 7, there is nothing here. Then 5, there is nothing. 2, nothing. So this is how I have found out that there are 2 pair of elements whose sum is equal to 10. Now we need an algorithm on this one. So I will show you first method. Let's look at the first method. See, I have to scan this array. So for this, I will take one variable I. Now for this element 6, I need a pair. So I have to check the rest of the array. So for checking in the rest of the array, I should use J. So J will help me find out an element such that whose total is equal to 10. So this J, I have to go on increment it. So using this J, I will check this total is not 10, then move J to the next element and check, is it equal to 10? No. Next, is it equal to 10? No. So in this way, I can go on checking the elements. So this procedure is same as how we were finding duplicate elements. Yes, it is same. Only the thing is, that time we were checking, is it a duplicate element? Now you have to check whether the sum is equal to 10. That's it. It's simple. And one more thing, I have taken unique elements. So there are no duplicate elements here. Like if I have 3, then 1, 7, then one more 7 I have. No, there are no duplicate. All elements are unique. So you don't have to worry about any duplicate elements. If at all there are duplicates, then you should remove the duplicates and perform this procedure. I will quickly write down the program code for doing this one. So let us see. For scanning through this element, I need a for loop. So I'll write a for loop for I assign 0. And I should go up to last element because I don't have to check this element, right? There is nothing beyond this. So I is less than n minus 1 and I plus plus. Then for every element, I should try to find a pairing element such that total is equal to 10. So for that, I need j starting from the next element onwards. So for that, I will start j, assign I plus 1 onwards. Then j is less than, till last element I should go, less than n, that is j plus plus. See, remember here n value is 10, right? There are total 10 elements. So the last element is at index 9. Now, what I should do every time? If a of I plus a of j is equals to given number, let us say given number is k. If it is so, then print both the element. See, the printf will print a of I value, a of j value. Like suppose I is here right now, I is here and j is here. So a of I value, that is 3, a of j value, that is 7, 3 and 7. So it will print 3 plus 7 is equals to k. So that is equal to 10. Yes. So we got the pair of element whose sum is equal to k. That's it. This is the end of loop and this is the end of loop. So that's all. This is the code for finding a pair of elements. Now, analysis. How much work we are doing? See, amount of work we are doing is similar to finding duplicates, right? See, being here on I on this place, we are checking rest of all the elements. So how many elements we are checking? Let us say n minus 1 elements. Then keeping I here, we are checking rest of the elements. So this is n minus 2. So this is same way, this is going till 1. So this is n into n minus 1 by 2 and this is order of n square. So yes, time is order of n square. So this is quadratic time taking procedure, right? N square means we say quadratic time taking procedure, right? Here n square doesn't mean exactly 10 into 10, that is 100. It doesn't mean that. It's n square, that is quadratic time taking. So if you look at the code also, here is a for loop. The outer for loop is there, so I can say it is n because it is going starting from 0 and ending at n minus 1. Then inside that, one more for loop that is also going till n, but from where it is starting? Just beside I onwards, right? So it's almost n. If you say no, it's reducing, so this was the analysis. Yes, n minus 1, n minus 2, that's how it is reducing, and the total is again n square. See, the degree of this polynomial, if I take the degree of this polynomial, this is n square minus n by 2, degree is n square, so we are saying this is quadratic. So even if I do detailed analysis for this one, it will be n square only. So I'm assuming roughly it as n. Now when to assume this for loop as n or when ignore it? Because in the previous example, I said that I wrote while loop and I said that it's negligible, we can ignore it. But here I am saying it should be considered. So for that, you should have the good understanding of the procedure that is being done here. If you understand the procedure, then you can decide whether it is considerable or not. You can judge that one, right? So this comes with practice. There is no formula. I cannot say that if this is starting from here to here, say n, otherwise do like this. No, it's all based on the procedure. So there are a lot of things to learn, right? So meanwhile, you'll understand how to analyze a procedure based on the code, right? So now it is n, and inside that there is one more n, so it is order of n square. So by reading the code also, we have found that it's taking order of n square time. So this is time consuming method. I want a faster method. So for faster method, again, the solution is hashing, hash table. So I'll show you how it is possible. So quickly I will show you that procedure. Now let us look at the second method for finding a pair of elements whose total is equal to given number, that is 10. This method uses hashing. So for hashing, I have created a table which is already initialized with zeros. The size of the table is 16 because the largest number present here is 16. So yes, already we have discussed that when you are using hashing, then you need a lot of memory, and it depends on the maximum element that you are dealing with. Now, what should be the procedure? So simply we will scan through this list of elements and we will use this hash table, increment the value or mark the value. Let us do it. And while marking, while scanning, what all we have to do, let us check it. So let us scan through this array. This is 6, right? Mark 6. Okay, this is marked. And for 6, which number is required to make it as 10? So 10 minus 6 is 4. Look for 4. 4 is there? It's not there. So there is no matching for 6. Then let us take I on the first element. Let us take I here. This number is 6. Now for making up the number as 10, we need 4. So check on index 4. Is it marked? No, 4 is not there in the list. It's not yet found. Maybe it's there, we don't know, but it's not yet found till here. So 6 cannot be a pair of element, right? So but 6 is there, so mark it as 1. Then move to the next element, 3. Now which is the element we need for making it as a 10? So we need 7. Go to the index 7. No, 7 is not there in the list. But we found the 3, so mark 3 as 1. So I'm saying count, I'm just incrementing the value, right? Then next is 8. So for 8, which number I need? That is 2. So go to index 2. So 2 is not there, right? So 2 is not there, it's not found, so there is no matching pair. Anyway, we got this 8. So increment this, so mark it as 1. Then 10. So for 10, I need 0. 0 is not there, but we got 10, so mark it as 1. Then 16. For 16, there should be minus 6. There is no such index. Then next, 7. For 7, I need 3. Yes, 3 is already marked. So it means 3 and 7 make a pair whose total is, sum is 10. So yes, we got the result. We will display this result and also will mark this as 1 because this is already there in the array. It is found. Then go to 5. 5 is marked as 1. Then for 2, we have to check 8. Yes, it is there. So 2 and 8 makes a pair and also mark it as 1. Then for 9, check for 1. 1 is not there. So anyway, it is found. So make it as 1. Then for 14, check for minus 4. Minus 4 is out of index. So anyway, this is found. So mark it as 1. So this is how we can go on marking the elements and finding out whether there is a element whose sum is equal to 10. So that's all. This is the procedure. Now what about the analysis? I will not do analysis. You know the result already because already we have used hash table, right? In the previous examples also. So the time taken is order of n, right? It's order of n. Now let me write on the code for this. So I will write on the program code which will use this hash table and find out a pair of elements. So here I will write down. So what I have to do basically, I don't have any work here. I have to scan through this array. Yes, for I assign 0 and I is less than, that is last element n and I plus plus. Then what I have to do every time. Now being here, I should check here whether 4 is marked or not. So check whether in the hash table at 4. So right now this is 6, so I have to check for 4. So that is nothing but 10 minus 6 I have to do. So 10 minus 6 means 10 is a k and minus 6 means a of I, right? A of I. See, 10 minus, for example, if it is 6 gives what? 4. So this will be h of 4. H of 4. We are checking at h of 4. If h of 4 is not equal to 0, means it's already found. It's already found. That means there is a pair. So what is the pair? So I can print these elements. So I am printing these elements. The elements are, that is a of I, that is the first element. Then next is the difference between them, right? We have checked at 4, so that is difference. So k minus a of I, that is the difference, and also k. So the output is first element plus second element is equal to k, that is 10. For example, it is 10. So this will be printed. If this is not equal, right, equal to 0. Anyway, after checking this, if it is found, then we will use this. Then afterwards, definitely we have to make this element, that is 6, as 1. I will increment it. So that is h of 6 as 1. So h of 6, what is 6? A of I. A of I as 1. So for 1, I will simply say plus plus. So this will increment. So that's all. So this is the procedure for finding a pair of elements with the help of hash table, right? So this algorithm takes order of n time. Order of n time. This is scanning through these elements only once. Yes, it's faster, but the space taken is more. So always remember this, there is a trade-off. If you want to save the space, then time will be more. If you want to save time, then space will be more. That's all in this video. In the next video, I'll show you how to find a pair of elements in a sorted array, if the array is sorted. In this video, we will solve a problem to find a pair of elements in a sorted array such that their total is equal to a given number, for example 10. We want a pair of elements A and B such that their total is equal to 10. So in my example, I have taken 10, it can be anything. So for any given number, we have to find out pair of elements if it is existing in an array or not. So already I have an array which is already sorted. So in a sorted array, how to find this, we will see. I'll show you the procedure. See, we want a pair. So first let us check whether there are any elements or not. Like, 1, 9, it's there. And 4, 6 is also there. Yes. So we have two pair of elements whose sum is equal to 10. So how to find out this? As the array is already sorted, all the smaller elements are on this side and the greater elements are on that side, right? So we want a pair of elements. So when there is a pair, then one number may be smaller and one number may be larger, right? Like 3, 7 or 2, 8. So that is total is 10. So smaller numbers are on this side, larger number on that side. So we can start scanning the array from either direction, from both the direction, to find one small element, one large element, so that the total is equal to 10. Yes, we will follow this idea. So for scanning through this one, so I will take I, that is starting on 0, and j on last index, that is n minus 1. Then using this, I will proceed in this direction, j I will move it in this direction. Then what I have to do every time? Check whether these two are equal to 10. No, this is greater. This is greater. 1 plus 14 is 15. That is greater. So when it is greater means because that number is greater. So this is greater. The reason is that number is bigger, right? So let us check a smaller number. So I will decrement j. I will not increase I. Let I be there only, right? Now again check. 1 plus 12, 13. This is still greater. So because of that bigger number, we are getting the result greater than 10. So let us decrement j only, right? Let us decrement j only. Now this one, 10 plus 1, 11. Still it is greater than 10. So decrement j. Now 1 plus 9, yes, we got a pair. 1 and 9 are together forming 10. So yes, we got a pair. Next, once we got a pair, then we should increment I also and decrement j also, right? Both are done. Both I have done. Now watch. 3 plus 8. No, this is 11. This is greater. So what should be decremented? When we are getting any greater number means it is greater than 10 means decrement j. Now turn comes. This is important. 3 and 6, it's 9. It is less than 10. Reason, the number may be more smaller. So let us go to little bigger number. So move I. So if the total is greater than 10k, then decrement j. If the total is less than k, then increment I. Now check them. 4 plus 6, yes. There is one more pair. One more pair of element whose total is equal to 10. Then move next. Then as we got a pair, increment I also and decrement j also, now they have met at same place that are on single element. So pairing is not possible. So stop the procedure. So this is the procedure. Let me write on the code and show you. Now for performing this procedure, we need I in the beginning and j at the end. So, and we are not incrementing I every time. We are not decrementing j every time. So we cannot use for loop. For loop will always do I plus plus or j minus minus. It will perform always. We don't want always, right? So we cannot use for loop. We can use, but the code will not be easily readable. So to make it simple, I will use while loop. I assign 0 and a j at n minus 1. Yes, this is here and this is here, right? Now how long I should perform this process? While I is less than j. Once they become equal, stop. Then what I should do every time? Check if these two are added, then the result should be equal to k. Check if a of I plus a of j is equal to k. If it is equal, then print. So I'll print three values, that is first number and the second number and the total. So the first number and second number, suppose it as 9. So 1 and 9 will be printed. So if it is equal, this is first case. And when they are equal, I should increment I also, as well as I should decrement j, right? Then second case, if they are not equal, then this total may be greater or smaller. So I will write down else if a of I plus a of j, that is less than k. If it is less than k, if it is less means the number is smaller, so I should go to the bigger number. So I plus plus, I plus plus. Else means the number is greater, so I should decrement j, else j minus minus, right? See, if they are equal, do this. If it is less, then increment I. If it is greater, then decrement j. So this loop will continue as long as I is less than j, and it will stop once I is equal to j. So this is the procedure. Now analysis. What is the amount of time taken? It's very simple. Just we are going through all the elements, scanning them once, right? From the left side partial and from right side we are taking partial. Total number of elements that we are scanning is n. So the time is linear. It is linear. Linear means n. So I should say it's order of n or big O of n, whatever you call it as. I'm calling it as order of n. So it's order of n. It's linear. Now at last, one more thing. See, I have used while loop here. Is it possible that we can do it using for loop? Let us check. If I write for loop, then this is a condition. Okay, I'll just write it I is less than j, right? Then this is the initial part. So I should be equal to 0 and comma j should be equal to n minus 1, right? N minus 1. Then this is the condition I less than j. Then what about I plus plus j minus minus? I don't have to do it always. It is based on condition. So leave it blank. You can leave it blank. So now I don't need these statements, right? Because they have become initialization part and this is the condition. So this is how the for loop look like. Now for loop is not having one of the statement inside, that is whether increment or decrement, what is done here, it is not there. So that is missing, so it will confuse the reader what is happening here. So it's better using while loop. Though you can use any one of the loop, or even you can use do while loop also. So that's all in this video. Now let us look at a procedure for finding maximum as well as minimum element from a given list of elements. We have already seen how to find maximum element, and even we can write a procedure. Similarly, we can write a procedure for finding minimum. But the question here is we want to do it simultaneously in a single scan. So let us see how it is possible. I have a given array here with some elements, and the maximum element here is 10 and the minimum element is minus 1. So that's what I want. Now how to find max min? So I have taken minimum and maximum, two variables. So let us start the procedure. The very first thing what I'll do is the first element 5, I will assign it to both. So both minimum and maximum are 5 now. To scan the whole array, so for scanning I will take I starting from here. Now every time I will check. What I will check? Is it smaller than min? 8 is not less than 5. Okay. Then check, is it greater than max? Yes, it is greater than max. 8 is greater than max, so modify max to 8. Then go to next element. Now watch this step carefully. Check this element. Is it less than min? Yes, it is less than min, so modify this. Now when it is less than min, you don't have to check it with max, because your number which is smaller than minimum cannot be greater than max. So don't have to check with max, right? So you can save one condition like this. Then next element. Is it smaller than min? No. Then check, is it greater than max? Yes, it is greater than max. So next it is this one. Next, is it smaller than min? No. So check, is it greater than max? No. That is 6. It is neither minimum nor maximum, right? Next, go to the next element. 2. It is smaller than min? Yes. Modify it. The next element. 10. Is it smaller than min? No. Then check, is it greater than max? 10 is greater than 9. Yes. Modify it. Then 7. Is it less than min? No. Check here then. Is it greater than 10? No. Then go to the next element. Is it smaller than min? Yes. Minus 1. Modify min to minus 1. Then next, this one. Is it smaller than min? No. Check, is it greater than max? No. So I have executed the procedure on the entire list, and we found the minimum as well as maximum element. So only the important thing that was to observe here is we can find it in a single scan, and if the number is not less than minimum, then we will check whether it is greater than maximum. If it is less than minimum, then we don't check with maximum element, right? So for this, I will write on a piece of code here, that is a loop that is scanning through a list of elements and finding maximum and minimum. So quickly, minimum is a of 0 and maximum is also a of 0. Then I need a for loop. That for loop will start from index 1 onwards, and the number of elements, as I have example of 10 elements, so I is less than n, that is 10, and I plus plus. So what I have to do every time, check if element a of I, if it is less than minimum, then modify min with a of I. If the element is not less, right, else, then check if the element is greater than max. If it is greater than max, then change max to a of I. That's all. This is the procedure. Procedure is simple. Now you can see that this is an else part. If this is true, this is done. Otherwise, this is done. Now analysis of this procedure. First thing, how much time it is taking. Time depends on the work done. So what is the work done? We are scanning through the list of elements. So how many elements are there? Some elements are there, n elements. So the time is linear. Yes, it is order of n. So first of all, the time is order of n. Now one more analysis I will do here. One more analysis. I want to know total how many comparisons are performed. Total how many comparisons are performed, right? Time already we have done it. So what was actually done when we said time is n? So in that time, what was done? The comparison and the assignment was done. Comparison and the assignment, right? Okay. So now I want to find out total how many comparisons are done. See, actually there are two comparisons. If this is true, then it will not go here. If it is false, then it will go here. So it means there are cases. Yes, there are cases. That is minimum time, maximum time. What is minimum time? Assume that always it is checking only this condition. It is not coming to this one. Always this is true. So when it will happen, if the list is in the descending order, like if you have the numbers like 10, 9, 8, 7, 2, and 1. So if you have a list in the decreasing order, then every time this condition will be true. 9 is smaller, right? 8 is smaller, 7 is smaller. Always this will be true. If the list is in descending order, then only this condition will be executed. So how many times the condition will be executed? As we are starting from 2 and stopping at n minus 1, that is n. So except one element. So total number of comparisons for this case, the number of comparisons will be n minus 1, right? One less. Then what about this one? See, if this is always false, then always it will enter into this one and check this condition. So in what situation it will happen that this is always false? So let us take the list. It is 1, 2, 3, 5, 8, 9, 10. Suppose the list is like this. Okay. If the list is going like this, that is an increasing order. So if I show arrow like this, this is a decreasing order. This is increasing order. See, this is minimum and maximum, right? Initially minimum and maximum. Every time I get an element greater than minimum, greater than minimum, greater than. So always it is greater than minimum, then always this condition will be checked. So how many conditions? Two conditions will be checked each time. So total number of comparisons will be what? 2 into n minus 1, right? This condition will check, it fails, then this condition is checked. So two conditions will be checked for n minus 1 time. So the minimum time is n and maximum time is also order of n. So in the best case, the number of comparisons are n minus 1, and in the worst case, that is maximum number of comparisons are these. So I'll show you something here. See, we have found out the best case and worst case. See, best case is list is in descending order, and the best case time is order of n, and if you are specific about the number of comparisons, then n minus 1. Then second thing, worst case. So case is different, time is different. Remember this. Case, define a case. What is a case? In which case the time will be more? The case is that the list is in increasing order, right? This is the case. And then what is the time? It is 2 into n minus 1. So it is order of n. This is also order of n. When we take the degree, it is order of n, and this is also order of n. But being specific, we want to know the comparison. So that is 2n minus 1. These many comparisons will be done. Alright. So time, we were saying order of n. Yes, in best case also, worst case also, it's order of n only. But the number of comparisons are different, right? So if you are concerned about this, then you can do the analysis. You can find how many comparisons or how much data movement is done. So that depends on you. So this type of analysis can also be done. So that's all, the best case and worst case. I'm not showing the complete program. Even I will not write down the code, and I will not give you a demonstration on this one. This you have to do it by yourself. So it's a student exercise. Declare an array and write down this code by yourself and check it. And one time you take this decreasing array and one time increasing array and debug it line by line and check how the comparisons are done, right? In this case, only this comparison will be executed. It will not enter here. Second case, it will execute both, right? So you can count them by yourself and you can see it by debugging it. So that's all in this video.